Recording in progress. So welcome everybody to lecture 7. Today, it's basically materials part 2. We dealt with reflectivity, roughness, color in the last part. Now we're going to be dealing with transmission, transparency, refraction, color in refraction, and dealing with some of the idiosyncrasies of Arnold's glass. Just like everything else, every software package has got their own little quirks, whereas in theory, everything should just work, right? You turn glass on, you should get glass. Problem with Arnold is you turn glass on, you get glass, but you do not get a very good shadow. Well, actually, you get no shadow at all. So that's where we have to come around and kind of add it in manually. And shadows are turned on. It's just that we need to do a couple of extra steps in order to get the shadow to be correct. All right, so office hours tomorrow. Really? Come on. So office hours tomorrow and Thursday will be pretty much 10 to 4. I don't have a meeting tomorrow, so that should be, yeah, that's good. All right, so tomorrow 10 to 4, Thursday 10 to 4, and then Frank or Ari will be doing the Zoom Open Lab for campus and online students, optional as always. Thursdays 1 to 5 p.m. Remember, all times at Full Sail are Eastern Standard or Eastern Daylight, depending on the time of year. So today, transmission, refraction, transparency, the index of refraction, which we briefly talked about when we were dealing with reflectivity, and then how the AI standard surface works with refractions. Don't forget tomorrow, Project 6, the material discussion and your research discussion will be due before midnight. So hopefully you guys are well on your way to putting the materials in your scene, at least the reflective part. And today we're going to finish up with the transparency. So reflective also included metal materials. All right, any questions about anything we went over previously? Anything about the reflective portion? Questions? No. About the zoomosphere? Anybody got any questions?
None so far.
Okay, good. All right, just checking. All right, so let's go and talk about what transmission is and what refraction is and why they are slightly different. Well, sometimes slightly is a misconception. It can be quite drastic, and other times it can be barely noticeable. All right, when you have a clean, clear medium for light to pass through, it will pass through usually unobstructed, meaning its path is not altered. That would be things like air, clear air. Even though we kind of think of air as being invisible, it is a big, basically, volume of gas that we swim around in all day, walk around in, if you will, breathe, helps everything grow. It can also include glass if it's clear and pure enough. And when it involves striking a surface, like glass, that light ray must hit the surface at a purely perpendicular angle. All right, perpendicular is the same direction that our surface normals face when we have a, normal on an average poly surface. Wherever it's pointed, it's always going to be perpendicular to that surface. So once a light ray strikes that surface, purely perpendicular, it's clear, it's clean, it can pass right through unobstructed. That is called transmission. So anytime you've got light passing through air, unobstructed, transmission. Go outside on a hot, humid day in the middle of August in Florida, and there'll be a lot of moisture in the air. And if you look out across the parking lot, you usually see little waves of moisture from the heat on the ground, kind of working their way up and becoming excited because they're hot. All right, that changes how light passes through because we are seeing those wavy lines. It is no longer direct transmission. The light rays are being refracted a little. They're being shifted around, not drastically, but enough. Does that make sense? All right, now, when we have a light ray hit a surface at anything other than a purely perpendicular angle, that is our incident angle. It could be off by 0.000001. It will start to refract a little bit, have its path changed. That also has something to do with the medium it's passing through. How much it will change depends on what the index of refraction is. That is a measurement of how light affects a surface when it hits it. It deals with reflectivity and also, in this case, transparency if we're dealing with glass, when a light ray makes it through a surface. Now, this doesn't have to be glass. It could be plastic. It could be water. It could be anything transparent. So once that light ray starts to bend, that is refraction. So our incident light ray will hit the surface. It will bend according to what the surface is, exit out, and then continue on its way. So you have transmission, where your path of light is not affected, even if it strikes a surface or passes through a medium. Anytime you've got really humid air on a hot day, or you've got a light ray hitting a surface like glass or a water bottle, anything transparent that light can pass through, if it hits it at anything other than perpendicular, it will start to bend. Now, other things can send it off its purely perpendicular course too. That could be things like there's a water droplet there. So now you've got a plastic or a glass object with a water droplet on it. So now it's got to pass through a couple things. That could change its path. But we're talking about best case scenario, where it's one object, it's clear, it hits it perfectly perpendicular. Does that make sense? Questions? Anybody in Zoom?
None so far.
Okay. All right, so let's continue on and talk about when we've got an actual object that is modeled correctly. All right, so first off, you guys have probably all modeled something similar to this wine or water goblet. All right, usually start with some kind of CV curve, start in the middle, kind of go around, you create a profile, snap it to the center so that the beginning and the end part of the curve are in the same plane, and you do a revolve, output polys, you're done. Now, why we have you model it exactly like that is because we want to have a surface that has actual depth in it, so that when a light ray, a camera ray, a particle ray hits it, it knows how to behave, so it can behave in a physically accurate manner. So out here, we would probably call this air. Air is fairly neutral. Right in here, this area right here, we would call that glass or plastic, depending on your point of view. What's going to be inside the goblet? Air. Unless there's something in it, I don't see any liquid in it. So unless there's something in it, it's going to be air. Right? Then we hit glass again. And then outside here, we've got air. Now, air has a very neutral index of refraction, 1.0. That basically allows light rays to pass through it pretty much unobstructed, or anything to pass through it. Glass has an index of refraction, usually 1.5 to 1.53. It's about the same. Then we got air again. We have glass. Then we have air. So we got a light ray coming in here, and it hits our surface. First thing that's going to happen is that camera ray or light ray or particle ray will query the material. It'll say, what are you made of? And it'll go, hey, I'm made of glass. My index of refraction is 1.5. So that ray will then bend according to the index of refraction, exit into air, which is neutral. So what it will do is continue on its way. Hit the inner wall of the surface again. Query it. What are you made of? Hey, I'm made of glass. You bend again, and then it's going to exit out. So in our ray's path, it basically has 1, 2, 3, 4 surfaces or objects to go through. So when we are rendering, we need to start to keep track of how many surfaces the camera needs to see through, light needs to get through, whatever is going on in your scene. We need to keep track of that so we have enough refraction rays or transmission rays. Arnold calls it transmission. Some other software packages call it refraction. Some call it glass. Some call it transparency. Doesn't matter what it is. It's how light will pass through that and what happens to it. So now, fortunately, most software packages will give you at least 4 refraction rays to start with. That way you can get an ordinary drinking glass or a piece of glass to look natural when you hit render without doing anything. But as we start to put a glass in front of a glass, and now the camera's got to look through 2 glasses, how many surfaces does the camera have to look through? Well, 4 for each glass, but if we've got 2 glasses, that's where you have to keep track of it. So it's going to be 8. And here's the good, well, the good part is it's only where the camera overlaps it. So if you have a shot where there is no glass overlap, that's good, because technically that will be a quicker render than if you framed up that same scene with a different angle, and all of a sudden you've got 2 or 3 pieces of glass for the camera to look through. At that point, you need to change your render settings so that you can get all the way through there, because what will happen is if you don't have enough refraction rays, it will stop at whatever point it reaches. So if you have 4, after that first glass, it'll shut down and you'll see nothing but black behind it. It won't be transparent. Does that make sense? So ordinary glass like this,
Sorry.
we've got 4 surfaces.
Sorry, do we have to take curve into consideration, like a glass's curve versus like a window that's pretty
Only
flat
if
plane?
it causes you more overlap. So for example, there is no overlap no matter how you turn this glass. even if you look through it from down here, you're still only going to get 4 surfaces. However, if you've got a glass with something like this, so say we've got a drinking glass, it sort of has that shape, but it's got a weird lip on it. Like that. So here at this point, well, let me go back to red. So at this point, when it goes through, it's only got 4 surfaces. But if your ray goes through here, you've got 1, 2, 3, 4, 5. You got 6. If it goes through here, you've got 1, 2, 3, 4, 5. Well, it depends. If it doesn't hit anymore, it'll be 5, 6. Let me erase that. But if you have something like this where it goes through just like that, then you're going to have, there we go. Then you're going to have 8 surfaces. Does that make sense?
Yeah, okay. Makes sense.
Yeah. So now, if we have a glass in front of a glass that's empty, you'll have 8. You have 2 glasses or 3 glasses that overlap. How many are you going to have? How many surfaces?
12.
Yeah, you'll have 12. Now, it changes if you have geometry inside your glass for liquid. So when we do liquid, we generally will select the poly faces inside the object so we can get the actual shape of the object. Duplicate those faces, scale them in ever so slightly, cap it off. And now you've got a solid object that is the shape of your original vessel. Could be any shape. So the thing about that is, though, it is considered to be pretty much a solid. Just like if you took a glass, filled it halfway with water, put it in a freezer, froze it, and then were able to get that piece of ice out of there, it would be a solid piece of ice. So it would have an entry point and an exit point. There wouldn't be any additional walls inside there. Does that make sense? So if we had in here, same thing here. So then we would have a different calculation. So we would have light ray coming in, bending, immediately exiting into an object that has a different index of refraction. Exit, bend, exit again. So now we would have 1, 2, we'd have 3, 4, 5, 6. So you'd have 1 here. You'd have 1 as the light ray exits the glass, but then immediately hits the solid object for water. Comes down here, exits the water, hits the glass, exits the glass, goes back to air. And each one of these would have its own index of refraction. Right? So we don't really worry about air. Air is neutral. So we don't need to take that into consideration. We have to take into consideration all the other things. So here we've got glass, which is 1.5. Got it. Entry, exit point. Now we've got ice or water. Let's call it water. that has an index of refraction of 1.3. You've got glass again. And then it exits into air. We still have air here. We still have air here. We don't worry about those. So we've got 1, 2, 3, 4, 5, 6 points. So 6 surfaces for our ray to pass through. You have 2 glasses. They each have water or liquid in them. They overlap to the camera. What are we going to have?
12, right?
12, exactly. Remember, it's additive. Now, if you've got those 2 glasses side by side, you don't have to worry about it. You only have to worry about, oh, each glass has 6. They do not overlap, so you don't need to add them together. Only where they overlap in visibility to the camera, because that's what the render sees. Now, to give you an appreciation of that, you know, when you're trying to run Unreal with real-time ray tracing, that's what it's got to do on the fly as you're moving around, is try to calculate, oh, right now, I only see these 2 objects. But as the camera moves, and all of a sudden you have these 2 objects now overlap each other, that's a lot of horsepower to render and calculate. And do collisions and particles and visual effects and whatever else is going on. And then the user decides, oh, I don't like that camera angle, and they shift the camera. So then it's got to calculate everything on the fly. All right, so this is going to be important when we start setting up our render settings, because depending on the camera angle, we might need to change our render. Usually we set the render settings up for what I like to call the worst case scenario. You got 2 shots. One of them has overlap, the other doesn't. Set it up for the one with overlap. All right, so we are back to, again, conservation of energy. Diffuse plus specular, which is reflectivity, plus refraction, which is transmission, equals 100%. Now our transmission is stealing all the energy from the diffuse. In glass, there is no diffuse energy. We have to cut that off completely. Color for glass comes from transmission. Basically, the transparency setting, which is right here. Glass color, whatever your object happens to be that's transparent. We turn the base weight off, so it's 0 diffuse. And we leave specular on because specular works with transmission. Glass is more transparent than it is reflective, but it is reflective. And also, this specular setting is where we have our index of refraction, IOR. This is where we set up for glass, air, water, alcohol, diamond, whatever it happens to be. They all have different index of refraction settings for the density of the object. All right, so like I said, they work together. Using one or the other alone may give you an interesting result, but it is not intended to do that by design. They are intended to work together. You create glass, turn the base weight off. That way you will get pure glass. By default, The transmission color will be white. White gives you clear glass. Any other color will tint that glass that color. So specular weight, we generally set that at 1. Specular color, we keep it white. Unlike when we were making red metal, which is the only time we turn that specular color anything other than white, for transmission in glass, it stays white. That's all about the reflections. The color for glass, again, comes from that transmission color. Specular roughness, that will give you half of the roughness for glass. There are 2 sets of roughness controls. There's one in specular and there's one in transmission, and they have to work together. So it's a little weird having to adjust them in 2 different places, but whatever you do for one, do for the other. And that will give you a true, what we call frosted glass look. Something like you take a glass, put it in the freezer, all right, you pull it out, the air is moister and warmer outside than it is in the freezer. So all that moisture clings to the glass, creates that frosted look. Same thing for privacy glass, only that's intentionally done. It's either etched in, sandblasting, or chemically etched. So we set our index of refraction. By default, Arnold gives you 1.5, which is glass. So transmission weight, if you turn it all the way up, it will give you clear glass, but we lose a shadow, which you'll see when I go to demo this. You lose a shadow. So this is where we have to put in what's called a gamma correct node into the transmission weight, and then we plug something called a sampler info, which basically tells the camera and the material where they are in 3D space so it can create an accurate shadow. Transmission color, as I mentioned, this gives you realistic color for glass. So here is the transmission extra roughness. Here is the specular roughness. They kind of almost look the same, but when you put them together, not only is the reflectivity rough, but also the transmission or transparency is rough now. And that gives you a true frosted glass look. Now, if you've got a glass that is not frosted, but it's not quite perfect and it's maybe older piece of glass. Older glass, you'll notice, is a lot blurrier looking when you look through it because of purity, age, whatever happened to the glass. It could, having got washed over years and years and years, constant washing, abrasion makes it rough. That is where you would add a little bit of roughness in the specular and a little bit of roughness in the transmission extra roughness. Go to Arnold's website and they say to make, glass rough, you need to do specular plus the transmission. Will give you an accurate result. All right, now, a couple other things we do with glass. One, we turn on caustics, which will give our glass a little more sparkle. Without it, it's transparent, but it's a little on the flat side. You really want to have as much sparkle in there as you can. So whenever we have something, it's really hard to see here. I'd have to see if I can turn on my flashlight here. All right, so I don't know if you guys can see it. Let me spotlight this. All right, so just a normal I would make a terrible weather person. It's like, wait, I'm going the wrong way. All right, so, well, that's not working. Let me come over to the projector. I'm going to take off my headset. And let me turn over here and see if you guys can see it. All right, so all the little sparkles here, right about here, those are caustic. That's light hitting the top, the bottom. It's kind of coming around, hitting both sides of the liquid, and just basically causing a nice little shimmery effect. Kind of like a pool, where you've got, little waves maybe in the top of the pool that creates that shimmery effect down below. So let's go back and, remove spotlight. Go to gallery. Okay, so those are caustics. We don't get them to that effect in Arnold, but it does help by making the glass a little more sparkly. We also will be increasing in the advanced section something called indirect specular that will kind of push the reflections and the sparkle in the glass along with caustics. That is the basic recipe for glass. Now, if we are doing windows, windows are kind of a little bit of a different animal. We don't have to worry about calculating refraction when light passes through a window. Why? Because do you ever model windows as an actual 3D cube? Usually you just slap a plane on, right? That cuts down modeling time. It cuts down rendering time. So what happens is, for the architectural industry and for anybody who's doing a shot of, outside a window, or you're outside taking a shot inside to the building or room, from the outside, you're passing through glass. You want it to be transparent. You also want it to be reflective, but you don't need it to bend light as you're looking through it. You really don't see refraction when you look through a window, unless for some reason you've got a window with nothing there and you can compare it to your, outside scene or on the other side of the glass. We have an option under the geometry section of the material called thin-walled. Thin-walled will allow the material to be transparent and reflect, but not calculate refraction, which is what we want with windows. So it's meant to look like a double pane window. If you do it to a solid object like a sphere, it will make that object look like a thin-walled ornament. Because if you don't turn this on, that sphere will become a solid glass object or ice or whatever it happens to be. All right, so ordinary sphere on a ground plane, dome light, image in the dome light. Did a couple of index of refraction renders. First one is air. Air is neutral. Notice no reflectivity, no transmission. Well, it's just transmission, no refraction. Now, the reason I have a shadow there is because you wouldn't believe anything was there if I didn't have a shadow. So you can see it. All right, next to it, index of refraction for water. In this case, I chose 1.33. Average is 1.3. You can see we have transparency, we have reflectivity, we have a shadow. We should have a shadow. Next to it, index of refraction for glass, denser. It refracts or bends light more. 1.52. Next to that, a diamond, which is really dense, 2.42, somewhere around there. It's much denser. It refracts light a lot more and it reflects a lot more because of that density of the material. So the higher the number, it's going to change the way light rays or camera rays pass through the surface. And usually these numbers, a lot of times you'll see presets under index of refraction. Some software packages will have a little pull down menu that'll give you some, oh, you want glass, it's 1.5. You want air, it's 1.0. Water, 1.3. If they don't, there are plenty of places on the web that will tell you exactly what this is, the index of refraction. In fact, the index of refraction.info database will have all this stuff there too. All right, so we talked about working with specular in the render settings. Now we need to talk about adding in transmission. Because you may have your direct light, indirect light, your reflections all looking pretty. Now we're going to have glass. So now you might have some noise in the transparency, that transmission part. This is where you crank up the transmission settings a little. Don't go crazy, because remember, it's being multiplied by the camera AA. Those camera AA samples, anti-aliasing samples. And put away that checkbook and credit card, because today only another special place for you to look for more ways to make your render go longer. So not only do we worry about in the render settings, the transmission section, but under the Arnold renderer section, which is where sampling is, you go down further and there's something called ray depth. And by default, Arnold has a setting of 8 for transmission, which means you could actually have 2 glasses in front of each other and be able to see through it. That's nice. Most software packages don't do that. But if you go any higher than that, then you need to crank up that number here. So in the sampling section, that's for noise. Here, this is for actual being able to see through it to make sure your renderer and camera have enough rays to use. Now, it's always going to be transmission is 8, spec is 1, diffuse is 1, and that's how they get the total. If you have to crank this up to say 10, and most of the time I recommend take the specular, turn it up to 2, so you get like a little more reflectivity. So if I do that at 10, put this at 2, keep diffuse at 1, what's our total number going to be? $13, yep. Remember, it's going to be additive. Transmission plus specular plus diffuse is going to be whatever they are, total. Now, transparency depth down here, if you've got it at 10, you might need to crank this up to 12 or 13, depending on how high you go. So, more fun with Arnold. Now, like I mentioned, you can have a render that will take a certain amount of time from one angle. Shot on the upper right this is before the days of Arnold's denoiser. Shot up there on the right, took 1 hour and 6 minutes to render. All my glass, there's no overlap. Change the camera, same render settings, double the render time, because now I've got glass in front of glass and there's overlap. So depending on your camera angle, the exact same scene could take twice as long to render. Just be aware of that. Right now, there aren't too many things that overlap that much, except for the Zen Garden. Zen Garden outside close-up, you've got wine glass, it's got wine in it, you've got a bottle behind it, you got overlap there. In fact, let's take a look at that. All right, so we've got a glass. We got 4 surfaces for the glass. We've got wine right here. There's 2 for the wine. And then we've got a bottle behind it. We got 4 there. But right here in this little sweet spot right here, what's the total?
12 total.
Okay, why?
Because like since the wine bottle is full of liquid, it would have.
Nope, the wine bottle's empty. It's only got 4.
Oh, okay. I thought that like because like the way the sun's in it, it looked like it had like a yellow liquid in it.
No, it's just the color of the bottle, and it's hitting a white
Yeah, so
kind of
just
sofa on the back. Yeah, so it's empty. So what do we have?
10.
Yep, we have 10. Good. So that's just the kind of stuff you need to look at. Let's go back to red here. All right, so these glasses will haunt you in the interior. So this one is called the Klein bottle. That one will be on the desk. You've got the vase that's over the TV. You've got this kind of rectangular old time bottle. That's going to be next to the sofa. And you've got this hourglass bottle. That's going to be 1 shelf down from the vase over the TV. So they're going to be there, but there is no direct overlap. However, for the Klein bottle, the way it is designed and the way it's built, how many surfaces does a ray have to go through, or does a camera have to go through here?
At most 10.
Okay, why 10?
Because worst case scenario, a light ray can go through the thin part. So I guess 1, 2, 3, 4, then through the thin part to the base of the bottom, and then again through the other 2 in the very bottom as well that are in more the foreground.
Okay. Well, let's count them. So it's basically, this is, if you've never heard of a Klein bottle before, they are kind of an enigma. They fill from the bottom and liquid, the neck goes through the body, comes out of the body, comes around, and then it fills the interior of the bottle.
Mhm.
So the bottle by itself has 4 surfaces.
Right.
All right. Now, this handle or neck, whatever you want to call it, goes into the body. So that's 4. The body itself also has how many?
4.
4. So worst case scenario, no matter what angle you look at this from, you're generally just going to get 8. Now, one special circumstance, which is what I thought you were getting at, JT, is if you actually look at it from above, this way, look straight down,
Yeah.
go here, go here, go through there, then you would have how many?
Wouldn't that be 12 then?
Yep, it would be 12.
12, yeah.
Yeah, so that would be technically worst case, but most of the time with a climb bottle, you're not doing an overhead shot, but it is possible. So we got 4, we got 2, we got 4, and then we got 2 at the bottom. So possibly in this camera angle, we'd have 12, but a side shot and most common shots, you'd probably only have 8 surfaces to worry about. One other thing that would definitely affect this little bottle right here has kind of a mushroom lip on it. Right at the top up here. So technically this bottle, if you didn't count that mushroom lip, would only have 4, but with that mushroom lip, looking through it all, it would have 8. And here we've got 4, so that's 8. So technically in this scene, we would have worst case scenario would be 8, no matter what camera angle you went to. Unless, of course, you had the climb bottle in front of the rectangle bottle in front of the vase. And then you'd have way many more. You'd have 16. Now, a lot of times you may render out and not notice anything. You might get away with not having enough in there, but at some point you're going to have somebody notice, oh, look, I can't see through that surface. It's all dark there. So you definitely don't want to do that in an art test. All right, questions? Does that make sense? Any Zoom questions? JT, Ashley, Carl, Donovan, Kenny?
One from me.
Okay. Carl's good. Thank you. Ashley's good. All right. So let's demo some of this in action. So let me crank up Maya. Let's go to the Zen garden. I'll pull up the day scene and I'll show you how to add in the wine glass and then the wine, and then we'll do the bottle. All right, so there is a definite order that you want to follow for this. First off, make sure you have reference before you start anything. Don't guess, oh, it's a wine glass. It looks like this. Get reference so you can verify, hey, it looks like this. Assign a new AI standard surface to all the geometry that you are going to turn into glass. You turn off the diffuse weight, leave the specular weight there at 1, leave the specular color at white, index of refraction 1.5. Then you go down to transmission, turn the weight all the way up to 1. That will give you clear glass. And then let's see what happens after we do that, because that's always the fun part. And by fun, I mean not at all. Here we are. Zen garden. All right, let me take my lighting. I didn't demo anything in the Zen garden last time. I did it on the interior. Daytime. Yeah, let's do that. And let me make sure everything is working as far as lighting. Okay, good. Nothing got hosed so far. Save as. Ooh. Lecture 7. There we go. All right, so first thing we want to do is I'm going to assign a new AI standard surface to the wine glass, the wine geometry inside the glass, and also the bottle. Now you'll notice that there is a label on the bottle. The label on the bottle we are not going to worry about for project 6. That will only hide the glass. When we get into textures, then we'll worry about it. But what we're going to do is take that geometry, throw it onto a display layer, and turn it off. This way you'll have it, but it's hidden, ready to go. So it's selected. Let's go up here. Let's just throw it on a new layer. Label. Turn off the visibility, and now we're good. All right, so I'm going to select my wine bottle geometry. Let's give it a new AI standard surface. And I'm just going to leave everything at the default just to make sure I get everything. So wine bottle. Wine glass. And then wine inside the glass. Oops, don't want to do that. I hit all. Huh. Okay. There's my wine. So now we're all set. Find reference. Let's go get some reference. Images. What kind of wine should we have? We got red wine, we got white wine, we got Zinfandel or rosé or pink or whatever you want to call it. Okay, we got one vote for red. What did you say, JT?
Rosé.
Rosé. We got one rosé, one red. 2 rosés. Ooh, rosé wars. Anybody else want to vote?
I guess rosé.
Okay, we got 2 more rosés. All right, rosé wins. All right, so Google Images. Oops. Really? And outside. And tools. Make sure it's as big as possible. There we go. All right, so one thing you want to avoid is super dark wine that's virtually impossible to see through, like this one. This one looks really weird. It looks like it's floating. So it kind of looks CG-ish to me. I don't know, that bothers me. That's not good. Something like this would work. You know, depth of field in there, but that's all right. Here you can see the wine's chilled a little bit, so it's a little bit on the frosted side, not too bad. You've got this, which would work. Ooh, I like that one. It's got a table, it's got a cutting board, it's got a knife, it's got cheese, it's got a wine. Well, that wine bottle won't work, but the wine will. Now, the only piece of clear glass we're going to have is going to be the wine glass. How do I know? Because it's actually in the instructions. So let's take a look at the refraction milestone. All right, so here's the exterior. Okay, wine glass, wine geometry in the glass, wine bottle. Wine bottle's empty. Wine glass is clear. The wine bottle needs to be a colored glass, and the wine inside the glass needs to be a colored liquid. Your choice. We chose rosé. So that wine bottle won't work, but everything else does here. So let's try this one. See first off if I can save it. Ooh, looks like it. There we go. Yeah, that'll work. All right, so I'm taking a look at my glass. It looks fairly clear, fairly pure, not perfection as far as transparency. So it is a little hazy, maybe a little blurry. So that's easy to do, but we've got wine, we've got a glass. So first thing we want to do is turn off, well, select the right piece of geometry, turn off the base weight. In fact, let's start rendering this as we're working. There we go. So base weight is turned off. We're going to keep the specular weight, color, index of refraction at the default. We go down to transmission, and all we have to do is turn up the transmission weight to 1. And we have clear glass. That's a little on the rough side, so I'm going to turn my roughness right now off. So now I have clear glass. But watch what happened before I turned off my transmission weight, I had a very nice shadow. As soon as I turned up my transmission weight, made it clear, my shadow disappeared except for the mysterious floating lump of clay in my glass. So this is why we need to do a few things in Arnold to basically get our shadow back. All right, so first thing we want to do is in transmission weight, we click on that checker input button. Transmission weight, click on it. That brings up our create render node. Normally, the things that are highlighted on the left side is what we would use, but we are going to use what is called a Maya utility to fix this problem. So create render node, under Maya, go to utility. We're going down to what's called a gamma correct. So they're alphabetical. We go down to G, right there, click on it, and that brings up the connection editor, and you say, oh my God, my life is over. No, it's not that bad. On the left side is your gamma correct. On the right side is the material. What we want to do is under out value for the gamma correct, expand it, click on out value X. On the right side, we want to connect that to the transmission. In this case, transmission is transmission weight. Click on it. Click close. Now we have a gamma correct plugged into our transmission weight. Now, we're not done in the gamma correct because we need to change. This is basically X, Y, and Z values. So this is X, this is Y, this is Z. What we're going to do, take our X value, turn it to 4. Take our Y value, turn it to 0. And our Z value, turn it to 0. And that's what we're going to track with the next utility. So in the gamma correct, there's a value connection. We basically click on the checker button, go to utilities again, and we go to a sampler info node. Sampler info node. Sampler info node, we want to track the facing ratio. What part of the geometry is facing the camera? And on the right side, we want to plug it into the value X of our gamma correct. And now we have a shadow that is accurate. So now we have a shadow. Now, a couple last minute things. Let's go back, select the geometry. We want to go down under advanced. And this is where we turn on caustics, which gives us just a little more sparkle in the glass. And we crank up the indirect specular to 1.1. That makes it just a little bit brighter. So this is our default shadow. This is with caustics turned on, and then this is with the specular weight turned up, or specular, indirect specular turned up under the advanced, just a little bit.
So when I did that process, my glass turned black again. It didn't, and it's not allowing me to, turn down the diffuse or turn down the transmission weight.
You can't turn the transmission down because you've got this plugged into it.
Right. And then when I did that, it's completely black. It's not clear like we see
Right.
here.
Because you have to, did you plug in the gamma correct?
Yeah.
Okay. And then did you change the settings here?
Yeah. I changed all the settings, changed the gamma correct. I did the sample and it's still completely black.
Sampler info node, you went facing ratio to out value X.
Facing ratio to out. Give me a second.
Now, since we're starting to work with networks, we can open up the hypershade. And in the hypershade, you've got the browser section, the create section, and this is basically the hypershade here, the node editor. So what we can do is we can graph our wine glass down here simply by right-clicking on it in the browser and graph network. And that will allow us to see exactly what's going on here. So this should be our facing ratio coming out into the X value. Don't forget the gamma correct out value X. Oops. Oh, come on. Don't do this to me. So out value X goes into transmission. Oof. My pen is wigging out on me. All right, so now basically we need to do the same thing for the wine inside the glass, but this will have color. So let's go select the geometry. Just going to grab it there. We're going to do the same process. Take the specular weight, or sorry, not specular weight. What am I doing? Base weight. That gets turned off, which will basically give us a lump of, looks like tar inside the glass. Keep the specular weight, specular color, index of refraction. This is where we have to find out what is the index of refraction for rosé wine. So we need to go take a look at the great Oracle Google. All right, so usually, well, let's start at the top here. ResearchGate sounds impressive. Abstract, not liking it so far. It looks like I got to pay for it. Nope, don't like that at all. Okay, that one's out. All right, fluids, alcohol, ethanol, methanol, propyl, crown glass. Way too technical. Let's do index of refraction, just wine. All right, so we got wine here. This is red wine. Probably work just as well. Looks like the index of refraction is 1.3445356. So 1.345 is probably average right in the middle. That should work for our index of refraction since we have 3 decimals. 345. That's for our wine. Now we need to go down to transmission. We can turn it all the way up. We've got clear wine, if that's a thing, but no shadow. So again, this is where we need to do a shadow for the geometry, so it can actually give us what we want. So again, transmission, weight. This is where we click on the checker button, brings up the create render node. We go under utilities on the left, scroll down to gamma correct. On the left side, the connection editor, gamma correct, out value X, goes into transmission on the right. We click close, take the X value under gamma to 4, Y and Z go to 0. Gamma correct value, this is where we plug our sampler info node in, which is a utility. We scroll down to S. This is where we take our facing ratio. We go up under value, expand it. We only want the X value. And now we have our shadow back. Very, very subtle, but it's there. So now we need to make it a color. Where is my wine? There it is, wine in the glass. There we go. All right, so easiest way to get the color in there, we can double click on transmission color and load our reference into the color wheel section. Under color wheel image, we click load. It's going to be on the desktop for me. There's our wine. And basically, I want to find an area that's not too dark or not too light. That's not bad. For color in wine, just like glass and light, they saturate very quickly. So I always like to try and keep the saturation, saturation, they saturate very quickly, but try to keep the color as pure as possible. Just like with light. You turn it down too much, it gets really dark and it's harder to see through. So saturation, going to turn it down a little. And let's compare it to the reference. See how we did. All right, not too bad. Don't forget, this is going to have a roughness level. And click done on your advanced color picker. This is going to have a pretty high roughness level, so I'm going to turn that down. There we go. Now, nothing has perfect smoothness. So I'm going to give this just a touch of roughness. I like to do like 0.01. And whatever I do in the specular section, I'm going to go down and give it a little bit of roughness in the specular roughness. Going to do the same thing for the wine glass. Going to go 0.02 on that since it was a little hazier in the reference. JT, did you get it figured out?
Yeah, I went through like the first step, but I didn't go through the second step. So that's why it came out looking black. So
Yeah, gotcha. All right. So what I'm going to do is for you guys, before I go any further, I actually have a checklist for making glass. So what I will do is upload it to Zoom for everybody. And I will also send a message to the class with it also. All right, so let's do that. So if you're watching this video, just pause it, make sure you're in HD, and take a screenshot of it. All right, so let's message everybody. And there you go. And in Zoom, instant gratification. There you go. All right, now, one other thing that I did not do for my glass geometry, or I'm sorry, my wine geometry, unlike the glass, I need to go down to advanced, turn on caustics, and turn the indirect specular up to 1.1. What that will do is make my liquid sparkle just like my glass. It'll also help remove some of those dark areas around the edges. Just a little bit of pop to it. All right, so not bad. Now we need to kind of find out what we want to do for the bottle. Now in the reference, the bottle has, where's my reference? Right there. So the bottle is clear, but we can't have a clear bottle for this exercise because we want to make sure you know how to make colored glass and make sure it's see-through. So let's go find glass we can use. All right, you want to avoid bottles that are full. The wine bottle is empty. Avoid anything with lights in it, which is a common thing to do now. Yeah. And don't forget, let's make the size large. All right, nothing painted. Well, that might work. Let's just go empty wine bottles. There we go. Yeah, there's a party right there. So we got really dark amber. We kind of got this olivey color. We've got a greenish color. Well, that should work pretty good. There's a bunch of others there too. I like this because it's sitting on the table, very similar to the Zen garden. So let's save it. So which one shall we do? Got the dark amber. We still need to be able to see through it, so it can't be super dark, but you can sort of see through this one. We got
the Chardonnay one, the first one.
This one, Chardonnay?
Yeah.
Okay, that works. So let's do the same thing we did for the other pieces of glass. I've already got an AI standard surface on it. Let's turn off the base weight. I'm going to turn my roughness down for now. In fact, where's my reference? Yeah, that's not perfect reflections. It's not bad. I'll give it a little roughness like we did. Maybe we'll give it 0.03. Just to haze it up a little. Maybe even 4. All right, so we did that. Next, we've got a shadow. We've got the right index of refraction. We don't have to worry about that. And then we go down, turn up transmission weight. We've got a perfectly clear bottle, which is fine, but we need a shadow. So we need to go ahead, gamma correct, sampler info node to fix the lack of shadow. So transmission, weight, checker button, utilities, gamma correct, On the left side is my gamma correct. We want to go out value. On the right side, we want to hook it up to transmission. In the gamma correct node, under gamma, X is 4, Y and Z are 0. Gamma correct value, this is where we plug in the sampler info. Okay, in the connection editor, sampler info on the left, facing ratio on the right, gamma correct value, X. Now we have a bottle with shadow. So at this point, we can add in the color. Let me just double click under transmission color. And this is where we're going to load our reference in. And we're going to choose that first Chardonnay bottle here. And we want to try to find an area where it's not too dark, not too light. Let's try and keep that value turned up a little. Let's turn down the saturation a bit. Let's see how that looks. Not bad. Questions so far? Hopefully that checklist helps, because then you can just go down there in order and you're all set to go. One other thing we need to check now. We've got a wine glass with 4. We've got wine geometry, which is 2. We've got a wine bottle, which is 4. So all that together makes up 10. Yep. And right about here is where we're going to worry about 10. Because now we've got liquid in there. So let's go sort that out. In fact, let's zoom in on that, because that'll be fun to render. All right, so it basically stops right when it gets about halfway through the bottle. So what we want to do is, well, let's go check our render settings. All right, that's good. Go down here under ray depth. So notice transmission, we got it set for 8 by default. We need to crank that up to 10. Like to bump up the specular to 2 just to give it a little more sparkle. So now we have to go, well, what's 10 plus 2 plus 1? That's what our total is.
Oh, 13.
13, yep.
I didn't know you were waiting for some reason.
13, let's do a render. All right, so now it's a little easier to see through. Down here, I'm going to give the transparency depth the same thing. just to make sure. So this is before cranking up the ray depths. This is after. So it does make a huge difference, especially in the reflections. And there's our nice little caustic in there from the wine bottle reflection. So we got the wine bottle. We need to turn on caustics. Crank up 1.1. So now everybody gets a place at the party. There we go. So once I crank up indirect specular and caustics on the bottle too, now everything comes up. All right, let's see, what does this look like from the render cam? Not too bad. Now I can always turn down the value a little bit if my glass is a little on the light side now. There we go. Just a little bit of value just to make sure that we didn't make the color too bleached looking. All right, questions? Anybody? About Zoom? Any questions?
I have a question.
Go ahead, Carl.
What does the transmission depth do for the glass by upping it?
That lets it change how it appears the deeper so if you had a big solid piece of glass, you know how it always looks really dark inside, but not quite as dark on the edges.
Yes.
It gives it a sense of it changing color as it goes deeper and deeper. A little like subsurface scattering, but we're doing stuff that is not that deep, so it's not really necessary.
Okay. Thank you.
Yep. That's a good question. Any others? All right, this is probably a good time. We'll take a break. We'll come back. We'll do the interior. I'll show you guys how to do the thin wall for the windows in the interior, because the interior does have window geometry, window glass geometry. We'll make that thin walled. We'll make an object, glass in there, just so you guys get a feel for it. And then hopefully you'll be set to do the rest of the stuff. All right, so let's see, it is 2:30 now. Where are we? Right here. Let's come back at 2:55. Let me make sure that will be uploaded and rendered. All right, so I'll see you guys back here in about 20 minutes. Any questions before we go? All right, questions in Zoom?
Nope. I'm good.
All right, I will see you guys back here in about 20 minutes.
See ya.